Hello everyone. We all know what is mean by sequence A n converges to L. But what is mean by A n does not converges to L? To know this, first we will just recall what is mean by A n converges to L. For every epsilon positive, there is a natural number capital N such that this A n minus L is less than epsilon for all n greater than or equal to n. Means after n, all entities should satisfy this inequality. That means what? In another we say L minus epsilon less than a n less than a n plus, L plus epsilon. That means after n, all these an's should be in this neighborhood, L minus epsilon to L plus epsilon, right? Okay. So in the graphically, if you want to see this is the 1, this is 2, this is n, and this is n plus 1. So if this is the L for every epsilon, if some epsilon is some fixed number, what it means, L plus epsilon, this point, and this point consider L minus epsilon, the length is epsilon. Okay, for every epsilon we can able to find n in such a way that all these an somewhere here, an plus 1 somewhere here, all should be inside the neighborhood, right? And for each epsilon positive, however the epsilon small, still we are able to find n. So what does means? It means these an's are very close to L after a certain stage. That's what it says, right? So on the up to finite point, it can be an can be anywhere. A1 can be here, A2 can be here, A3 can be here, or it could be inside. We don't bother about the finite points whether it is in that neighborhood or outside. Only after that certain stage, all should be inside this. So an converges to L means what? For every epsilon, these are should except the finite point, all should be inside. Or another way to say that for every epsilon, only finitely many points are outside that neighborhood. That also we can say, right? So from this, an does not converges to L. How we can say? See, to clear the exam in one course, in one class, we need to pass all the subjects. To fail in that class, you need to fail any one subject enough to fail that class. So the same way, to tell an converges to tell, for every epsilon I need to get that n. Okay, in such a way that all this should be in that neighborhood. N does not converge to L. If there exists one epsilon positive in such a way that this is opposite, like what it means, these an's are outside that neighborhood. How many an's? Infinitely many n. See, here what we say, for every epsilon only finitely many points are outside. To say something is not true, there is one epsilon, infinitely many points are outside that. Then we are done, right? There exists one epsilon such that this an minus L is greater than or equal to epsilon for infinitely many L. See, here you have to notice it's not for all n. I'll tell with the example. Only if infinitely many n this is true, then we can say that for some epsilon, we can say that n does not converges to L. Okay. Take the example 1, 2, 1, 2. You know that I have given already the video. Why it is not convergent. You can watch, a link will be given. You can watch that video if you want to understand. See, take L equal to 1. L is 2 or any real number. It is not a limit point for this sequence. But through this definition, what we need to find? We need to find one epsilon. You need to find one epsilon such that this inequality is true. Then we can say an does not converge, right? So what is that epsilon for this? We'll find, okay? See, our ANs are what? ANs are either 1, L is fixed 1, or ANs are what? Either 1 or 2, right? Here it is 0 and here it is 1. So if I fix my epsilon equal to of, this is greater than or equal to of or epsilon, right? And see how many 2's are in this sequence? Infinitely many. All even terms are 2. So infinitely many an that an minus L are greater than or equal to epsilon, we are able to say for some epsilon of. Then this L is not a limit point of the sequence. Similar way 2 is also not a limit point of the sequence. So we can say any real number, if you want to take some other real number, if you want to say L, that also we can say 1 minus L or 2 minus L, it will come. So epsilon we can choose in such a way that that is greater than or equal to this number, right? So no real number is a limit point for this sequence. Okay. Thank you.